Alright, welcome back. It is Unit 2-2 there, and we're now going to jump all the way up to Chapter 7 in our textbook, but still we're in the proper unit here on integer exponents. Integer exponents. We're going to build upon what we saw yesterday with our exponents here. And we're going to move forward. Just a little reminder, remember if you see these icons, watch only, jot something down of notes or some practice problems. Okay. Alright, still in Standard 2.0. Today we will learn to evaluate and simplify expressions containing integer exponents. Integer exponents. So here's an exponent and a base. This is our vocabulary for the day, which should look familiar from yesterday. For example, what would be our base here? Hopefully you recognize the base is 4 and the exponent is 2. And this 2 here tells the 4 to multiply itself twice, and of course we know that's to be 16. 4 times 4 would be 16. Alright, take a look at this one. Also remember that when multiplying numbers with exponents, if the bases are the same, just add the exponents. So for example, if we have 3 to the 4th times 3 to the 3rd, well, we could also look at it like this. How many 3's do we have? 4. How many 3's do we have? 3, for a total of how many 3's? Well, the answer, of course, is 7. So this is actually 3 to the 7th. What's a faster way of doing that? 4 plus 3 would be 3 to the 7th. Also, remember that when dividing numbers with exponents, if the bases are the same, we simply subtract them. So this is something you may have seen earlier, but we're going to go over it quite extensively here. If we're multiplying, we're going to add. Well, what's the opposite of multiplying? Dividing. What's the opposite of adding? Subtracting. So if you've got 3 to the 7th power over 3 to the 2nd power, if you stretched all those numbers out, it would look something like this, where you'd end up with 7 3's across the top and 2 across the bottom. And we know that we can cancel numbers that are the same top and bottom. So if we take those away, what are we left with? Well, we're just simply left with how many 3's in the numerator? 5. And then at the denominator is a 1, so we don't have to write that down. So 3 to the 5th power. 3 to the 5th power would be our answer here. A faster way, of course, what's 7 subtract 2? 5. Alright, maybe you jot these down here. Here's a little practice guy. So, simplify each and leave an exponent form. How about this? 3 to the 2nd times 3 to the 2nd. Would you say 3 to the 4th? You're multiplying right here, so we're going to add the two exponents, 3 to the 4th. How about this one? Now we're subtracting again, just like our previous example. 7 subtract 2, that should get you with 3 to the 5th here. How about this one? Y to the 4th times y to the 2nd. Y to the 6th power. We're multiplying, so we add them up. Here we're dividing again, so you're going to know to subtract the exponents if the bases match. The bases do match. So m to the 6th over m to the 3rd is m to the 3rd. How about w cubed times w cubed? I'll use that word cubed from yesterday. Let's see, 3, we're adding because it's multiplication, so w to the 6th. And now, this is kind of a tricky one here because it looks like the number in the numerator is smaller than the number in the denominator, but that's okay. Just use a negative number for now. We're going to end up with 8 to the negative 2, right? What's 3 subtract 5? Negative 2. Now, that's going to lead us into this, negative exponents. 8 to the negative 2. It's going to be more the case that you're going to not be able to leave your exponents in negative numbers. We're going to need to figure out how to write these with positive values. Let me show you a little trick here. When you have any base to a negative exponent, what I want you to do is multiply using the exponent by ignoring the negative sign. So what is 8 to the 2nd power? 8 to the 2nd power, we know that is 64. But because of the negative sign in front of the exponent there, step 2 says if the exponent is negative, your answer is a reciprocal. What's the reciprocal of 64 over 1? Well, it's simply 1 over 64. So what you can do here is ignore the negative sign, multiply 8 squared like you normally would, and then write your answer as a reciprocal. Let's try this one. Now, of course, this one should be in your notes also. We've got 3 to the negative 3, so I'm going to ignore the negative sign. So what is 3 to the 3rd power? 3 times 3 is 9, times 3 again is 27. Because of the negative sign, write your answer as a reciprocal. So it's going to be simply 1 over 27. 1 over 27 is your final result. Alright, one other thing to remember. The sign of the exponent does not determine if your answer is positive or negative. So keep that in mind. Just because you have a negative exponent, that doesn't mean the base becomes negative. And finally, one more reminder. Any number to the 0 power is what? Remember from yesterday? Any non-zero number to the 0 power. So anything other than 0, the answer is 1. The answer is 1. Okay, we learned that yesterday, and there's a reminder for you. All right, so try these practice problems on your own. Let's see, I'll give you a few seconds here between 3 to the negative 2. Now, if you need to pause the video, now is where you can do that. So in class, I would just keep going. But here you have control, so go ahead and pause it if you'd like. Jot down an answer, hit start, and just go back and forth until you get done. So 3 to the negative 2, you're looking at 3 squared is 9, and the negative sign says write your answer as a reciprocal, so you should end up with 1/9 as an answer. How about this one? 5 to the 3rd power. Is this a positive or negative exponent? Well, it's positive, so it's 5 times 5 times 5. The answer is 125. How about this? 6 to the negative 1. 6 to the negative 1. Negative sign. Let's ignore that for a second. What's 6 to the first? 6. But because your answer is, because the exponent is negative, let's go ahead and write your answer as a reciprocal. Instead of 6, it's 1 over 6. 6 to the negative 2. We'll follow the same reasoning there. 6 squared is 36, so your answer should be 1 over 36. How about this one? A little bit trickier here. Negative 5 to the negative 2. Yeah, negative 5 to the negative 2. So, I'm going to end up with, I don't see any parentheses here, so I'm going to just take it one step at a time. What's 5 squared? Well, that's 25. 25. And now, because of the negative sign out front, it changes the answer to negative 25. And because of the negative exponent, you end up with a reciprocal, so it's 1 over negative 25. 1 over negative 25 right here. 12 to the 0. Well, 12 to the 0. Any number to the 0 power is indeed what? Well, it's 1. The only exception being the number 0. 0 to the 0 is what we call indeterminate, which we don't have right now. How about negative 3 to the negative 3 power? So it looks like kind of a trick question here. Negative 3 is your base. Your exponent is negative 3, so you're going to go negative 3 cubed. Negative 3 times negative 3 is positive 9. Times negative 3 is negative 27. So you know your base is going to be negative 27, or your answer. Now, what are you going to do with it? You're going to write it as a reciprocal. So you should get negative 1 over 27. Remember from last year that negative sign can be top, middle, or bottom. Doesn't matter, it's still a negative fraction. How about this one? 10 to the negative 2. So you should be pretty fast at this now. 10 squared is 100, and then you write your answer as a reciprocal. 1 over 100. Alright, that's it for Unit 2-2. So if you'd like to see more, take a look at this website. There's your keyword to type in, and there's your video examples. And don't forget your question for tomorrow. All right then, we'll talk to you soon.